This session is about continuous integration, the experience that we have at Dell, more specifically on the department that I work on, which is Dell Financial Services. So I will give you more details. So just to start with, just a little bit about me. I have a lot of experience as a full stack developer in .NET with a few JavaScript experience. I work at Dell since 2010, all right, and I am a Salesforce developer since 2012. So I have been taking some certifications and some courses in Salesforce, and I have been using communities, Sales Cloud, Service Cloud, and a lot of Salesforce stuff. So, just talk about a little bit about the challenge that we were overcoming here at Dell. Initially, in 2011, Dell created a financial services org. We basically at Dell we have many orgs. So the DFS is the org that I currently work on. We offer financial products to our customers. And in 2011, we created this org with a very limited set of enhancements specializing in Sales Cloud. So the first product that we launched was Sales Cloud, so our sales team could enter their opportunities, their accounts, their stuff there. And then the most challenging thing started when we opened up a new region, the EMEA region, where we have a backend where we needed like Service Cloud, and we also had other things like a partner portal that we need a lot of enhancements. So that's where we really started to have a lot of custom code and other than just customizations over Salesforce. And that's where my talk is going to be mostly focused. So our continuous integration, I will talk more about it, is around the code, but also related with the customization that we built. But you will see later on. The other thing is, on the very beginning when we started, our process was quite cumbersome because it depended on manual process for a very few amount of people that was involved in that process to create the package to deploy in other environments. So we rely on very few engineers to create the package and then to deploy to our SAT environment. That's what we call and our UAT and performance, and then later on in production. So that process could take a long time, and the time to catch errors that we would see would take a long time. So then from developer to catch an error that could happen because the changes that were created would be incompatible with the others would be like maybe half a day or something like that. And with this process, we reduced a lot of this time, and we were able to catch things much earlier. So just a quick summary about our agenda that we are going to talk. The tools that we are currently using. Currently, we are not using any type of product like GearSet or any of those tools. We basically created our own tool set based on Force.com migration tool and TFS. So we also created some internal tools for ourselves for data loads that I am going to speak later how that works. But mainly, we are basically created our own tool set to build our own code and also to deploy for production and SAT environment. So, as you can see on the slide, here is basically how our deployment works. So this is actually to give you an introduction how we merge our code and we are actually launching to non-production environments for our users to test it. So basically, it always starts with a developer fetching the latest code and then merging that on the TFS. And then what TFS is performing is that's watching a specific branch that's created for a particular release. And then deploys that code on what we call package sandbox and test if everything is all right. If everything is all right, we store that package, which is basically a combination of metadata and data loads on TFS to make sure that we will be able to deploy that later on either SAT environment or production, exactly the same change. So the idea behind our process is that we basically package ons, so we build ons, and we deploy many times. So we deploy over environments, we deploy over SAT environment, over performance environment, and over production environment, exactly the same package. We don't create distinct packages for each environment. So here I just wanted to show you a very simple scenario where this is basically a simple package that is using metadata API and also data loads. It's basically a custom library that we built along with our build. So as you can see here, this is going to deploy the code. It's going to show me if everything is all right, and then you will see after that if everything works, the data load will kick off. As you can see, it just started. This is our real simple data load and a real simple deployment, so it took quite fast. But that is the core functionality of our build process. It actually performs both metadata changes and data load changes. So we merged both together in order to be able to automate as much as we can through our development process and also during our production launches for our business. So how that works, the integration with TFS. I'm not sure how many of you are familiar with TFS. All right? No, that's good. So TFS is basically a source control, but I also have another module to build code and also to call other stuff. So in our scenario, we just started with XML file, and we are calling ant. So our TFS integration with Salesforce don't have so much intelligence. The intelligence of our build process is actually on the build file from the ant. So that's where the process to first have some data loads being performed and then metadata being deployed and so on and so forth is actually on the build file for the ant. So it's pretty standard. So it's basically called the ant with the correct parameters, which is not very complicated. It's basically like if you want to call ant on your local machine, that's basically what we are doing with TFS. We are not doing anything much fancier than that. And here is more focused on one step before what I showed before, which is when the developer starts to create something. So whenever a new feature comes, developer gets the latest source code, and then with the latest source code, as you can see in the bottom, he either going to be developed locally, like a class, for instance, that you might develop locally and then you would push to the Salesforce, or either you might go on your sandbox and then you would pull that to your TFS and merge it with the current branch. So there are those two scenarios. Basically, we perform the second scenario like with objects and profiles and things like that. So, but for other things like classes, we basically perform the first one, which is developed locally, and then push it to Salesforce. The third step is what I already mentioned, which is merge with TFS. So whenever you make changes on the classes, or either on the object, or either on a profile, you would merge with TFS, and then check if there are any conflict, and then you would push to TFS, and then this would start what's showing as number 4 at top, which is our current CI process that you probably are most interested in, which is basically run the deployment, run all tests, and make sure that both metadata changes and data loads are working as it should. And another thing is we also sometimes need to perform some deletion of components. So we also cover destructive changes on this scenario. So let me move forward just to show you how that really is showing up on our TFS. This is basically showing up the process of the deployments. All right. So whenever you merge that branch, the developer branch, with what we call production branch, that I'm going to explain later, that process starts. And as you can see, I'm basically deploying the same package that I did through the command line, through the ant. So the output is quite similar. The main difference is that I don't have to manually go and type anything on the ant. So the process is really started by TFS, and the logs are all stored on TFS, and then I can see if everything was wrong. Everyone can take a look and see what was missed or encountered any type of error. Okay. In order to work on that process, we also established a branch model. And basically our branch model is based on some advices from ALM Rangers. Basically, they are a team in Microsoft that talk a lot about TFS and what are the best practices to use TFS, which is on our current scenario. Okay. Here, actually, the left image is all the way around. So our development environment, our development branch, sorry, which is from ALM Rangers on the top. On our case is on that other pictures on the bottom. So we basically have one release branch for we have one branch for each release. So if we have R4, we have one dev for R4, for R5, and so on and so forth. We also have one what we call release or production branch, which is the next image, which is where we merge to deploy later on with SIT environment and then with production. So that is what, if you will, is like our release candidate branch, if you will, and so we have most of the changes happening on developer branch, and then later on merged with release branch, which is then promoted to SAT environment and further on to production. We have what we call stage environment. So it's a parent of all of those branches, which is whenever we have a new release, it's coming from that stage branch, because after our release is performed, we basically merge back to that stage branch. So then we have a clear picture of what was deployed in production and what changes were applied. So then we can start from that point and wouldn't miss something that we performed on a previous release. And then we have our main, which is quite similar to the stage. That there are some differences sometimes, but usually after we deploy, we merge with stage, and after like the end of fiscal years, we might merge with the main back. So that's one of the differences we'll have. Don't try to read the whole slide, but those slides are going to be available. But here is basically just a set of very important folders that we have on our own structure. Okay, so like we have the data folder, which basically have all our data loads that are part of that release. So like if I would like to load some opportunities or some custom objects or accounts, so on and so forth, the files and the instructions to load are going to be in data folder. We also have a lib folder for some of our custom libraries and some libraries that we use from Salesforce as well. But the most critical folders that we have are two: the manifest and the source folder. The source folder is self-explanatory. You have the classes, the customizations like objects, profiles. But the manifest is basically the file that tells our build system what components are being changed on that particular release. Because, for instance, on the source, we have all the classes, but we are not deploying all the classes all the time. So that's what we are doing. And the same for objects and sharing rules, etc. Here are just some very quick considerations about what APIs to use. Okay, so the first of all is like metadata API that currently they are incremental. So you need to embrace that fact. So you shouldn't be deploying over and over and over the same components because this will take longer. And you might end up overriding some stuff because like merging classes is easy. But merging XML files like objects, profiles, and this type of stuff might become cumbersome if you have so many customizations, which is our case. For data loads, the only advice that I would give is around bulk loads that usually there is a delay associated with it. So if you are just retrieving or inserting very few records, it wouldn't be the best fit to use a bulk load, bulk insert, things like that. So it's sometimes you would rather prefer inserts through REST or SOAP directly instead of using bulk API before going with bulk API. If you have so many records, that's the best use case. So here are some examples. For some ideas that we got from some other people that are on the industry, also using some continuous integration processes. And for us, there are two steps that we are looking to, which is we are also trying to remove one step of that process because today you have to check in dev and then you have to merge with prod. So we would like to keep that on the same step. So whenever you have a check-in that already generate the package, but at that point in time, we were a little bit afraid of doing that because we were not quite used to that process just yet. So that's why we end up having two steps on that. And another thing is we are also removing some of the changes that exist on objects and profiles to not over deploy it again and again. So because for some things to store just the delta is quite simple, but for objects sometimes it's a little bit trickier because when you perform a retrieve from the sandbox that you are currently developing, you are getting mostly everything. So then you might need to merge the XML file and then perform some changes on what was retrieved, and there are some tweaks that you might need to perform. But that is something that we are already doing, and we are going to improve on that area as well. So, in our CI process is based on the fact that if something, basically someone said that if someone hurts, you need to perform it more often. So that's basically it, So our process was quite simple. Our set of customizations were more or less simple, but then we become more and more complex. And instead of saying, hey, okay, we are going to deliver last time for our business because that process is cumbersome, we actually started to doing again and again and again in order to make that process faster and simpler, even for ourselves, in order to be able to deliver more and more in our environments to make sure that it really works. And one of the reasons why we actually started is just on the slide is because we started a portal which have a lot of features being customized through to Visualforce pages, through Apex, and so on and so forth, that required a lot of knowledge and a lot of effort from several teams And if we were just relying on that manual process, that project wouldn't be possible because, as I said, we had a lot of Apex code and Visual Force pages to maintain, and we had like we discovered that things would break just too late on the game, then that would be a big challenge for us. So that's why we really started to that journey. We all know that this is not nearly perfect, but we are still improving that process, and we are looking for a lot of things that Salesforce have showed us, like Salesforce DX and a lot of other stuff that are upcoming. So, all right. So, anyone have any question? Yes, each developer have their own. So your question was okay. Your question is if every developer have their own sandbox. On our case, we are using sandboxes, right? Because we are using an unmanaged package. So yes, each developer have their own sandbox, and then the first point where they merge is TFS. So then that's why we have that CI process, because that CI box is never being changed manually. So we are always sure that everything that was merged is going to work later on. So, but yes, each developer have their own sandbox, because in our experience, if we use shared sandbox, they might end up overwriting customization or code, and we lost productivity already using shared sandboxes.
Thank you. So is it possible to do multiple parallel deployments? As you said, you were showing multiple branches of stage, release, and stuff. Can we have release 1, release 2, where release 1 is this week and release 2 is next week, and developers are merging a common code, for instance, working on a common functionality? So how do we manage such changes?
You mean like parallel development?
Yes. Yeah, parallel.
Okay, yeah, parallel development is a little bit challenging, right? It's still possible, but the thing is, depending on how parallel they would work or when they will end up, that might become challenging. Because, for instance, if you have like a parallel just for a few minutes, a few days, for instance, like a hotfix or something like that, then you probably are going to merge to stage and then back to your dev release. So then you are covered. But if you are developing two different things for a long period of time, then you end up having a more headache to merge those things together later on. So this is more around how much time you are going to keep parallel development than if it's really possible. On our scenario, basically we have like 5 feature teams, and all of them work on the same branch. We are not separating through feature branches, for instance, if that's your question.
Is there any process to update the dev boxes?
No, actually there is, right? So whenever you check in the code, I have not shown it here, but yes, the idea that is each developer have their own sandbox. So after they check in the code, so everything is fine, all tests run, we have a process to deploy the same package into the developer sandbox. So then we are able to synchronize the developer sandbox with the latest code that is going to be deployed on further environments. And the developers can also perform an ad hoc build to their own sandboxes in case they wanted the latest source code being developed in that release. Okay, we still have 5 minutes. Any questions? No?
So I have a question. So if I wanted to start doing that kind of integration, what would you recommend as the first steps?
I think one of the first steps that I would recommend is aligning your current process, understanding what are your pain points, right? And then trying to think on how those steps can be automated. One thing that was very important for us on quite of the beginning, that I believe that we should do that even earlier, was to establish a a branch structure. So it was all clear for all developers how they work. But when we really started on the very beginning, we have not a clear structure on how we were structuring the branches. So then it was more difficult in order to automate the deployments itself, because we wouldn't have. It was harder to identify the snapshot that must be promoted to other environments. So I think it's good to have a clear branch structure in place to start with. So otherwise, that might become messier.
Thank you.
If all developers have their own sandbox, you recommend to developers to refresh their sandbox from the prod regularly?
That really depends, right? Our cycle is more than like a few days. Is sometimes like 1 month from dev to production. So what we do is that, as I was answering his question, is that we have a build that deploys exactly the same package that is being deployed in SIT environment or production, deploying on the developer sandbox. So on this case, then you have the latest code being developed on that sandbox.
There is no risk if developers started to edit the same code in their developer sandbox?
There is some risk around it, that's true. But there is the same risk if you perform like a refresh of that sandbox. The difference is that with that, deploying the code from the package that you are developing that release means that because they are not yet in production, the refresh is just going to wipe out, and I will have to add the changes again somehow.
Because if they refresh directly from the prod, they are autonomous and they decide when they do that and what they can back up before refresh and store again.
Basically, what we do is that after our production launch, we perform refreshes of developer sandboxes and also SIT sandboxes, performance, so on and so forth. But inside of the same window of a release, during development of a release, we are basically we're not performing refreshes. So, but it's a very, very good idea. You know, if you are I would recommend that every time that you are performing a production launch, that you refresh your sandboxes. That would be my recommendation, and that's basically what we do.
Thank you.
You're welcome. Another question? All right. So thanks everyone for coming, and I will post on the chatter later on the slides. Thank you.